The screw-cutting lathe is a machine tool used to cut threads on a workpiece, such as a screw or bolt. It was invented by Henry Moseley in the early 19th century and revolutionized the manufacturing industry by allowing for the mass production of interchangeable parts. This led to increased efficiency, standardization, and precision in manufacturing, and had a significant impact on industrialization. Before the screw-cutting lathe, the production of screws and other threaded parts was a labor-intensive process that required skilled craftsmen to manually cut threads by hand. This process was slow, expensive, and often resulted in parts that were not interchangeable. The screw-cutting lathe automated the process of cutting threads, allowing for the mass production of standardized parts that could be easily assembled. The screw-cutting lathe had a profound impact on the manufacturing industry and led to the development of many other machine tools and manufacturing processes. It allowed for the production of complex machinery and engines, such as steam engines and locomotives, and helped to drive the Industrial Revolution. In terms of improving the screw-cutting lathe, modern technology has led to the development of more advanced lathes that can perform more efficiently and with higher precision. For example, some modern lathes are designed with computer numerical control (CNC) technology, which allows for the automated control of cutting tools and can perform complex operations with great accuracy. There is also an increasing focus on sustainability in manufacturing, and efforts to reduce the environmental impact of the manufacturing industry. Modern lathes can be designed with more efficient cutting tools, reduced energy consumption, and better waste management practices to minimize their environmental impact. Finally, there is ongoing research into new materials and manufacturing techniques that can further improve the efficiency and precision of the screw-cutting lathe and other machine tools. This includes the development of new cutting tool materials, such as diamond and cubic boron nitride, as well as advances in additive manufacturing, such as 3D printing, which can produce complex parts with high precision and efficiency.